Hello, my name is John Hooker and I'm an engineering manager here at Statistics and Control Inc. Today what we're going to do is we're going to go over our OptiRamp solution, specifically our OptiRamp Liquid Pipeline Solution, and talk to you a little bit about the process behind creating the model, simulating the model, and then viewing some of those calculated outputs that we get from the model. So the first step is actually creating the model here and talking a little bit about our OptiRamp software. So pretty much how our customers are using our software is it's an advanced process control engineering suite, and basically we're looking at real-time simulation, and from that real-time simulation we're able to optimize the process, whether that's looking at being able to optimize batching and sending shipments in the best manner, or sending different batches when it's cheaper to do so. Another aspect is allocation factor, and just being able to show that mass balance from point A to point B and making sure that you're not losing anything in there, as well as pump scheduling for optimal line pack or energy savings in there. So there's quite a lot that we can do with our software in terms of flow delivery, tracking losses, as well as even the algorithms like condensation, leak detection, congealing. We have quite a lot of different algorithms that help in both gas and liquid pipelines. But today we're going to focus specifically on liquid pipelines. And so the whole purpose behind doing this is building a model and then being able to simulate that model. And with that simulation, we can do quite a lot of different things. We do a lot of what if analysis, or a lot of times people ask us to do dynamic studies on their pipeline to help either solve a problem. And with it running in real time, one of the nice things is you're able to rapidly assess any issues or any unplanned events in that. And one of the things that we've experienced in all of our pipeline operations is that all customers tend to do it a little bit differently. And based on the objective function and value stream, but we can still use the same OptiRamp tools to get that done. Pretty much here is a great slide on just showing the setup of what we're going to simulate. So here at the beginning side of it, we have our product tanks, and so you normally have either just oil, or if it's different batches, it comes from different product tanks. We're not going to get too involved into our tank solution. You can always contact us and we can talk about it. We're mostly going to focus on this pipeline as well as the pumping stations. Normally you tend to have several pumping stations along a pipeline, and I think in our model today we have about 11. And another important aspect is the DRA injection and the metering skid, sensors along the pipeline, different pumping stations, as well as the endpoint. And most of the time the endpoint can either be a refinery or it can be to different customers as well. It just depends on where the pipeline's going. And so with that modeling, one of the things that we got to take a look at is what specifically we're going to model. And here in our process, we have pumps, pipes, pipelines, control, block, and gate valves, engines, motors for those pumps, fluid properties. That really comes into importance when we're talking about batching, and also with the mass flow balance in there as well. And here at Statistics and Control, all of us are control engineers. And so we tend to like to look at the unit control, the station control, as well as the pipeline control. Because a lot of situations that we run into tend to be each operator looks at the individual station, or looks at a couple stations, but they don't really take a look or think about that overall pipeline control. And so our system really helps with knowing, okay, this is what's going to happen 2 hours down the pipeline. This is what's going to happen 4 hours down the pipeline if you have those process disturbances, and helps react to it. So when we build the model, we we simulate it, and then we can take a look at the production and transportation of the fluid flow, pressure, temperature, density. We have all of that. We can see the pipeline dynamic behavior. We have a large operational range to help reliably replicate the process. and our system can respond to process disturbances because we're taking live data, getting it into our simulation, and constantly updating our calculations in order to see this is how the pipeline is operating live. So you can see the liquid property changes from batching, changes in operating conditions, as well as energy costs is another important aspect with how much fluid the pump is going and how much it costs to run the pump and run the station and run the entire pipeline. So here in our OptiRamp developer, OptiRamp is a suite of software that we build the model, we run the simulation, as well as we can view it through our web browser, which we call Web Analytics. And here, this just shows how we model our pumps. We basically create all the nominal parameters in there and allow us to create the pump performance curves as well. The next slide is just what the pump performance curve looks like. One of the nice things about our system is it allows us to take a look at this is what we enter in as the baseline model, and then as we're getting live data in there, we can actually see how that pump curve changes from what it's supposed to be to what it's actually doing. And a lot of times you'll see, okay, this pump curve moved maybe 2%, 3%, so it's still operating pretty efficiently. It's still operating how the manufacturer thought it would be. And then at other times we can see that they move quite a large amount, whether it be 10%, 20%, and especially when that happens, it's time to either take a look at the pump or do a little bit of maintenance on the pump as well. And so the purpose of the pump curves is just to show how the pump's operating and how efficiently it's operating in that. For our pipes/pipelines, one of the things is we're very detailed in the model, and especially with our thermal model, it helps get all of this correct because you need a pretty accurate thermal model when it comes to especially congealing and condensation and the pressure drop that's happening along the pipeline. So here we use Oem Specifications, so it's pipe schedules, pipe sizes, length, elevation, diameter, and we'll take a look at how this looks in our actual model. And here what we'll do is we'll just go ahead and go to our OptiRamp developer, and in the OptiRamp developer we already have all of the model up. And here you can see on the left hand side, this is how we build the model, and we basically build it based on the entire pipeline. And what we did was we divided it into each individual pumping station as well, so that each individual pumping station can be ran as a simulation separately, but it all goes together and passes flow from one station to another through the pipeline in here. And so we model the tank. We start off with our tank. It goes into the station 1, which is this block guy here, and then comes out station 1 and then passes through to this pipeline. And this pipe is about 18,000 feet long, it looks like. And so here it's not that long of a pipeline, but then it goes into the Station 2 model. And if we go ahead and look at these submodels here, we can see how we do that, where each submodel has its own pumps, valves, sensors, pipes, everything in between. And you can see that we try and model everything in here, as well as the control valves in order to control it. If we go ahead and take a look at Station 2, what we'll see is we'll just see that not all the stations are the same. So some may have 2 pumps, some may have 1 pump, they may be in series, parallel. In this particular one, it doesn't have any pumps. All it has is just a branch of an incoming flow that comes from a different producer. And so that's another important aspect to take into account in the pipeline. Here, just to take one last look at a station, we're going to take a look at Station 5, and as you can see, it actually has 4 inputs, and it inputs into a couple of different pipelines that are running along here. And here you can see this little needle point right here is where we're actually injecting DRA into the pipeline. So we do model the DRA as well. And so with this system, one of the things that you can do is, now that we've built the model, we can take a look and see how the simulation runs. But before we do that, we're going to take a look at our pump library like we were talking about earlier. Here you can see this is where we enter in all of the information for that. Here's the nominal parameters that we can enter in, as well as if it's has any flow conditions, let the operator know. This is your possible range of operation, so we can have flow minimum set points in there, flow maximum set points. It just depends on what they want to see, and then we are able to build the map based off of that. So this is kind of the original map in there. So now that we have the pump and valves and pipelines and model built, we can actually go and take a look and see what's going on inside our simulation. So here in the simulation, you have this chart area on the top left side, and that's what looks like the model that we saw inside the developer. And here it starts off with station 1, and then here's that same pipeline, and you can even see that station 1 looks the same inside that pipeline. With this just shows which elements of the model are on. And for a pipeline, it's a pretty straight line of just everything tends to be turned on. And here in the middle part of this is our island section, and this shows the actual calculations that are going on inside that particular island or inside the pipeline. So here, if I just zoom in a little bit more, you can actually see how big the pipe is, and you can see all of our different calculations that are going on. So here we're calculating viscosity, velocity, temperature, flow, and pressure. We can also calculate density. Pretty much any of our calculations you can see in our internal trend viewer, as well as they're displayed on the web a lot of the time. So it looks like this first pump is actually being bypassed, and so it's not taking into account any pressure change in here. It looks like it's just bypassing that pump. And then here it's coming into this first pump and going through, and then it'll exit station 1 and move on to the next station. And it's very similar with station 1 and station 2 to go all the way down the line, all the way to the end of the pipeline. Up here on the top right, you can see our pump curve. And actually, like I said, this dark yellow line is going to be the original equipment manufacturing curve. And then this yellow line is our adjusted curve. So you can see it hasn't adjusted too much based on actual operating values. But it is going downward just a little bit. With all of the simulation comes what we really want to do is our optimization. And here in the bottom left corner, we can take a look at our optimization. So what it's doing right now is it's taking a look at our initial data that we have for station 1 and each individual pump, station 2, all 11 stations are in here. And it's taking a look at what the pressure's doing, what the DRA is doing, any control valves that are in there. It's looking at all of our constraints, which would be the minimum operating pressure, the maximum operating pressure, coming in and going out of the station, as well as the cost. We actually calculate a cost function or current cost to the pump just to let the operators know how much it costs to run the pump right now. And so if we scroll all the way down, you'll see that it goes through all the different stations, all the different manipulated variables. Any valves that we have in here are control valves, so we can put a position at the control valves or adjust that and see how it does. If I go ahead and hit start, what it will do is it'll actually take a look at a few different scenarios and run through and find kind of the most optimized positions for our manipulated variables. So it's looking at, can we lower a DRA point? Can we increase a pump speed? Can we lower a pump speed? Maybe can we change a control valve to make sure that we're still able to deliver our target flow to the end of the pipeline. And so that's what it's trying to do, is it's trying to help deliver that target flow there. So if I click on start, what it'll do is it'll go through these different scenarios that you have, and you can actually see on the top here the different scenarios that they are. The first one is our initial scenario, or how it's operating right now. The second row, or the second column, is the optimized scenario. So it's not turning any pumps off, it's not turning any pumps on, and it's just taking a look at, okay, if we adjust DRA, if we adjust the VFDs, if we adjust the control valves, we can actually find a little bit better of an optimized look at this. And in this particular situation, we're trying to save energy or save money in this. And then another thing that it looks at is, okay, what happens if we turn a pump off? What happens if we turn a pump on? And how does that balance against the different solutions that we have? So if we scroll all the way to the bottom here, we have a total cost included in this particular row. And basically, right now we're operating at about $1,320 in our station. And then here, if we optimize everything, we're operating at about 1,112. So we're saving a little bit of money in terms of dollars per hour on this. And the way that we're saving money is taking a look at, a great example is just this DRA flow in station 11. So right now we're flowing it at 39 parts per million. We're saying, hey, if you drop that to 0, you'll save some money on that. And the change that you're going to get, though, is right now we are running at about 700 psi in the pipeline, and that'll kick it up to about 966 psi in the pipeline. So it's all about looking at those trade-offs and what you can do and the different ways to take a look at it. And it looks at a couple other scenarios. So here, what happens if we turn Unit 5 and Station 6 off? Here, what happens if we turn Unit 6 and Station 6 off? And it shows the different costs evaluated with that, as well as the different manipulated variables in it. So this is a great way for a engineer or an SME to do a dynamic study on it and just see how it's running. Or again, if you just ask us, we're happy to work with you and take a look at how your pipeline is operating and maybe give you a couple of suggestions on how to improve it as well. And so most of the time we tend to have this simulation and this optimization running in the background, and we prefer to have our customers view it through our web analytics. So what I'm going to do is hop onto our web analytics and take a look and see just how it looks from a web analytics standpoint. And so here I go to my web analytics, and it opens up, and we'll take a look at this top picture here first. And here you can see the entire pipeline, how it's operating, what it's running at. And a lot of times people tend to like this dynamic image and this dynamic line here because it shows how fast it's flowing. We can actually make it to where if it flows too fast, it can go too fast and provide a warning. Or if it's flowing too slow, it can provide a warning as well. Basically, one of the things that we've learned in working with a lot of our customers is that people like to have everything kind of at the click of a button or within 1 or 2 clicks from each other. And so with this dynamic line, we're able to add pipeline profiles in here so you can see how the elevation changes through the pipeline. You can see how the pressure changes. Right now our flow doesn't change that much. You can see just the oil line pack and how it's responding, as well as the amount of head that is needed in order to get move the liquid from point A to point B. So this is just a great overall flow. And then another important aspect of it is our measured flow. So that's what's reaching the end of the pipeline. And then our target flow, which is the aspects that we want to hit, as well as our max flow. So a couple of these things are very key for looking at our key performance indicators. And here we do target compliance, we do efficiency, utilization factor. Normally the target compliance is, are you hitting your goal? Are you hitting your target? Yes, you are. No, you're not. It's kind of important to know whether you're hitting your target or not. And then efficiency is just letting you know how efficient your pumping station is operating. And then the utilization factor is just how much of the pipeline are you using? Are you actually using it all? We found that customers really like to have these 3 things available just to it lets the operators, it gives them a point of reference to know where they are right now and where they need to go in the future. And then if we take a look on the pump image page, we have the pump map, we have the same key performance indicators. And one of the nice things is just being able to take a look, see the tags for each pump and how it's running. You can see quite a lot of images from it. It provides pop-up pages. It's pretty much however you want to design it. Another nice aspect is just including initial data right here in case you forget how the pump's supposed to operate, what you're supposed to do. We can do that as well. So our web analytics has quite a lot of information to provide in here, and it's a really great resource for the operators and engineers alike. So if I come back here, this just explains our pump optimization a little bit more. Again, the optimization algorithms automatically run, so you see them in our web analytics. It takes into account pipe pressure limits, helps reduce energy consumption, increase savings, maximize pipeline productivity. And then here, the whole purpose is taking a look at how much it costs versus how much it could cost with optimization or with adjusting some of those manipulated variables in there. And so we normally like to front and center the cost savings in that. So pretty much it was a very quick demo for us. And if you want any more information, please visit www.stctrl.com. And if you want to see the full-blown version of this demonstration, feel free to contact us. Or if you just want to talk to me a little bit more, reach out at sales@optiramp.com. Thank you for taking the time to listen to me, and I hope you enjoy the conference.